Welcome to a two-part series where we'll show you how powerful web components and WebRTC have become, with some help from Webpack. Everything that you now see is running as a web component with the help of WebRTC. I'm even able to connect to other physical devices and to other browser tabs. And all of this is made with super modern JavaScript, and I'm going to teach you everything about it in this two-part series. Welcome to the first part, where the focus is on web components, not WebRTC. That part I'm going to cover in the next video, so subscribe if that sounds interesting to you. I have also written a blog post at Cisco further discussing some elements in this video, link in the description below. We can't make this application directly using only web components, as we are missing some crucial features from modern frameworks like routing and state management. That's why we're going to make our own small framework on top of web components with the help of Webpack. This will help smooth out some of the shortcomings of web components. And a quick side note, creating a framework is actually not as hard as you think. The core elements are surprisingly easy to make, and a lot of the work on major frameworks goes towards edge cases, documentation, optimization, and actually getting people to use it. I'm doing neither today, so this will go a lot faster. So, let's get started. The entire project is available on GitHub, link in the description below, and you can try out the demo I just showed you online if you want to right now. But before I dive into the code, I just want to remind everyone what a web component is, in case someone is new to this or have forgotten it. Web components consist of three elements. The first one is custom elements, or the JavaScript part. The second is HTML templates, the HTML part. And the last one is Shadow DOM, or the CSS part. They are universal and everlasting. This is now part of the JavaScript standard, which means that web components we make today should work in 20 years. And they can be used in every single framework. And you write them with super modern JavaScript. It's amazing to work with. Here you can see an example of a web component in just one file. We start at the top by declaring some general HTML that's not part of the component. Then we are using our component. The way you know that this is a web component is with a dash in the name, as no built-in HTML elements have a dash in their name. We're using it before it's declared, and that's allowed. Next up, we're creating the template. This is some reusable HTML that's going to be the body or the content of our component, but this is a template, and that means it will not be rendered in the HTML document until it's being used by a component. Here we're declaring some styling that affects everything, but this will be view encapsulated, which means that the Shadow DOM will prevent this styling from affecting anything outside the component, so only the inside part should be styled. Then we're declaring the actual component by creating a new JavaScript class. Yes, that's allowed now. By extending HTML element. This is sort of the base element for all custom elements. And we have to call its own constructor as well. The next thing we do is setting up the Shadow DOM by creating it and sending it to open. This just means that it's accessible by JavaScript. Then we find our template and get its content and clone it into our own shadow. That means that this HTML becomes this component's view. And the last part is just going against a global object, custom elements, and saying that this tag is now associated with this class. So, to summarize, each time the browser finds our element, it then looks up that name in the registry here and check which class is associated with that element and creates a new instance of it, which then in turn creates its own Shadow DOM and copies the content of this template into its component, and then the component is created and renders. Now we're finally ready to view some code and the project. The structure is going to look really similar to Angular, and it's a really good reason for that. Angular has based their structure on how web components are structured, so I sort of have to use the same structure as I'm, using web components. But in general, I have components, services, modules, routing, a build system, and super modern JavaScript. Let's look at some code. Here we have the project structure. At the top, we have the dist folder, which contains the output of the build from Webpack. Then in the package file, we're defining some scripts that are just, well, serving and building the system. And then a series of dependencies. These are just dependencies for Webpack. There are no runtime dependencies for our application listed here. All of the important elements are now in the src folder, where we are declaring all of the components, assets, services, and setting up the actual application in index.js. Here I'm importing all of the components, setting up Firebase, I'm going to come back to that, and defining all of our custom elements based on what we are importing. And I'm also declaring some directives. I'm going to show you what that is later. We can look at a simple component like the About page, which has 3 files, the CSS file, all the styling, the HTML file, well, all the HTML, and the JavaScript file containing the declaration of the component and all its logic. This structure where declaring them as separate files is really useful for me, but you can have it all in one file if you want. Then we have the index.html file where we're importing some of the global fonts, declaring the global styling, and using the most top level component, our router. And I just want to mention that this is a guide on web components and not CSS. I'm using modern CSS here with imports and CSS variables, but I'm not going to show any more CSS than this. But let me know in a comment below if you want a video on the CSS part here. And here you can see the actual application running. You can go to, for example, the About page and see that the route changes and use the browser button to go back. And when I create a new room, the other tab will automatically join as well using something I'm going to show you in the next video. And then when I click, it connects and I can see myself in this video chat. And I can also have a conversation with myself over the chat system. And all of this is using WebRTC for communication for both the video and the chat. Web components have some crucial limitations, and this is the reason I'm using Webpack on top to help solve some of these problems. The first one is HTML import. This is the problem where you have to declare all of your templates in one file, as HTML has currently no way of importing one HTML file from another. So if you have 50 HTML elements, then you have to declare all of them in one file. That's not really sustainable. The next limitation is dead HTML. This is the problem where the template have no reference to the class, as it can be used in several different elements. So you can't write onClick and this dot some function within the class. That's unfortunately not possible. Next up, we have CSS shadow piercing. This is when you actually want some global style to affect every single component, like for example from a design system. And lastly, we have browser support. And as long as you're not using Internet Explorer at all, then you should be fine. But now, some good news. All of the problems listed here are solvable by using Webpack, and I'm going to teach you it in just a few minutes. Webpack is all about merging all of your project files into one file. It does this by crawling all of your JavaScript files and combining them into one file, and it also includes HTML and CSS files most of the time. And it also offers live reload. That's when you change some code, it's going to compile it again and reload the browser for you automatically. And hot reload, where it only replaces the small part you actually changed. Webpack can do a lot of other stuff like compiling TypeScript and Sass, but I'm not going to use that here. And here you can see Webpack in action. It's combining all of the project files into one and opening the browser to a new tab with the result. And here you have the scary Webpack config file. This is where we're defining how Webpack should function in this sort of giant JavaScript config object. It's going to be really simple after I've shown it to you. And it all starts with the entry point, or where should it start crawling, finding files to combine. It starts in the index.js file. And here it takes this file and everything that's imported. So it goes to the about page, for example. It's this file and everything that's imported from there, and so on, and combines all of them into one file and outputs it as something.bundle.js, which in the dist folder is something.bundle.js. Then we're targeting the web. Then we're setting up the source map. You might not know what source maps are, but it's actually really simple. Because this is going to be combined into JavaScript and minified. So it's going to look like this. And it's really hard to read. And if you get some error message in the console, then you're going to be like, something crashed at D. What is D? Source map says that this random variable corresponds to some actual variable in your source code. So it's just a way for the browser to help you get better error messages. Next up, we're defining the dev server, or we're just saying how it should function. Like, it should work from the dist folder. See on top here, the dist folder. Some general things like public path. It should open when you're opening it for the first time. We're not using hot module reload right now. And it should live reload when you change something. And we should enable the history fallback API that's used for our own routing system. I'm going to come back to that. Then we have something called modules or loaders. What is that? The reason we need loaders is because Webpack does not understand stage 3 JavaScript or lower. Okay, what is that? JavaScript changes all the time. New things are added, and that's done via stages, where stage 1 is the first and stage 4 is fully implemented and standardized. The thing is, Webpack refuses to understand or implement anything that's not stage 4, and web components are still just stage 3, so you're going to use something called a loader to help Webpack understand that. And which loader are we going to use? Well, we're going to use the big one. We're going to use Babel. And I'm going to teach you Babel as well here today. Babel is all about converting new JavaScript to old JavaScript so that you can use modern JavaScript before it's fully supported in all browsers, or in this case, in Webpack. But it makes code slower because one line of modern JavaScript is converted to potentially 100 lines of older, less efficient JavaScript. But it allows us to use modern features before they are fully ready, and that's why Babel is so popular. And we can actually look at all of the stage proposals or things that JavaScript hasn't landed fully yet, but Babel allows us to use right now. And here you will have a master list of everything that's on its way to becoming a standard part of JavaScript, and there's a lot of cool new features on its way in the future. Back in the config file, we're saying that every time we're hitting something like a JavaScript file or module.javascript, excluding the null modules, we're using Babel or saying that Babel should process the file before it's handed off to Webpack. The Babel config is really simple. It just says use the default setting, stage 4, and add in support for classes and for private methods, the two things that Webpack can't understand yet. And then we also have a loader for HTML and CSS. I'm going to show you later why this is important, but it's just taking the HTML file and CSS files and giving us the raw content as a string. Then at the end there, we have some plugins that add some extra functionality to Webpack. The first one is Clean Webpack plugin. It just clears the dist folder between compiles. I just removed it for now as I want to view the files. Then we have the HTML template plugin because our index file does not have a reference to the main bundle, so it will not load if you just open this. But this copies the file over, and if I extend it, you can see that the bundle file is linked here, so it's going to be loaded at runtime. Next up, we have the copy plugin, which just copies all of our assets because I have some asset files that I just want to be copied directly, like an image of my cute dog, and some CSS files, and this is copied over directly to the dist folder. And at the end there, I'm just telling Webpack to optimize even more if I'm running in production mode. And that is Webpack in a nutshell. You should now be able to understand this file. There are some ways we can extend it by adding TypeScript and Sass, but I'm not going to cover it in this video. And Webpack, with all the optimization I've added, makes the entire application less than 20 kilobytes. That's nothing. And Firebase is the only dependency, and it's loaded from a CDN at runtime. You might not realize how small 20 kilobytes actually is. Like if you open the bundle file, and now it's minified, as you can see, but if you decompress it with Prettier, you can see that it's only 504 lines of total code. Like here you can see some of the variable names being reduced, but not all of them. Like some of them are still their full name because they can't be reduced due to the JavaScript standard. So here we have the entire website plus the framework in just 500 lines of code. That's really amazing. One of the reasons this application is so small is because all of the dependencies for web components are shipped with the browser. Like when you're using React, Vue, and Angular, then you have to ship that library alongside your application. But web components are a part of JavaScript, so it's shipped with the browser. But now we're ready to create the framework. I just have to say up front that I have taken some shortcuts here to make it easier to understand, but all of the core elements are here, and we're starting with creating components. A good place to start is with the About page. This is a really simple page, just a title, image, and a back button that takes you back to the main page. Here we have the definition for the About page. We're defining the class with a constructor where we're setting up the actual shadow, and a function that allows us to go back to the main page. And at the top we are importing the HTML and CSS for this component from those two files, and it's done with the help of the raw loader that allows us to load them as strings. Now we can look at how the component is actually being created, or the view for it, because we have the setup shadow function that takes in the HTML, which is some simple elements, and the CSS, and we want both of them to be applied to the component's view or template. And that is done in the setup shadow function. This is a really simple function. We're just starting out by creating the shadow root, then creating an in-memory template, not getting one from the index.html, and setting the inner HTML for that component to the global styles, plus the CSS, and then appending the HTML as well. Then we're getting the template content and cloning that into our own shadow DOM. But there's one thing missing here. Like if we open the About page, we can see that we're doing this.back on the onClick handler. And I said that that wasn't possible because the HTML file had no reference to the JavaScript file. Well, we can do a little hack that will solve this for us, because at the time we're creating the actual shadow root, then we have both the reference to the HTML element and the component. What we can do is save the reference to the component in the window object. This is a global object that's always available, and then replace all instances of this dot with window.component name or the reference to the component. If we open the About page in the browser again and inspect the button, we can see that the reference is now set to window.component3.back. And that actually means that we can go in the console here and get the reference and execute the function ourselves manually, like that. So now we have fully functional components that are easy to write, as we can reference elements in the component with this dot. And it's the same way I'm doing it in different components, like the home component as well, setting up the shadow and being able to do this dot something. This way of structuring elements is really similar to Angular if you have ever used that. The final step is to define those components, because this is not being used at the moment until we import it in the index file, as you see here, and define it against the custom elements global registry. And I'm also defining something called a directive here. What is that? Directives are a new feature with web components where you can extend the existing element to add some extra functionality, but then you're not having your own view or CSS anymore. You're reusing the one from the actual component you're extending, in this case, the input element. If we open the text input, we can see that we're not setting up any shadow root here. We're just appending some logic to the input element. As you can see here, we're extending the input element. We have a connected callback that's called automatically by the browser when the component is created, and one when it's destroyed or removed from the DOM. And this just adds some extra functionality where we're validating or adding some form validation, just adding a red border around the element if there's no value inside it. And here you can see the actual input element where we are form validating, so it's red with no input, and when you add something, it's not red anymore. And this directive, as I call it, is applied by using the is syntax. So we're saying input is text input, and that means the JavaScript class is now associated with this component, and we can add some extra functionality. Really neat feature, but it's still really new with web components. The next thing we need is services. This is where we put our shared logic and application state. These are singleton classes, meaning that there's just one instance of them in the entire application, so all components talk to the same instance. And that means we can add some state to it. So what I want is that all of those variables here refer to the same instant, even if I'm newing up new versions of it. And this is actually kind of easy in JavaScript, because you can do some magic with static and the constructor. Because in the constructor you're able to return another instance of a class and it will switch to that one automatically. Meaning that the first time this is created, the instance is saved as this, and the next time it's just switching to that instance. And that means all of those variables are referring to the same instance. Meaning you can new it up in all of your components and all of them are referring to the same instance. We can see this in practice by console logging the random number and seeing that the number is the same for all instances, even if it's newed up separately. And I can now use this technique in my project to get singleton services in an easy manner. The first time, the reference is saved, and from there on, it's just returning that initial reference. And then I can use it really easily in any component by just newing up the service, even multiple times, and it will always refer to the same instance. And a quick side note, this is how modern JavaScript classes look. You can define them with the class keyword and add static properties and private properties with a hash symbol. It might look a bit weird at first, but it's a lot easier than typing out private each time, so I'm actually starting to love it. A more advanced version of the service system I just created is what Angular has with its dependency injection system. Here we are just asking the framework for instance and it's giving it to us for us and we're not newing it up ourselves anymore. I'm going to go deeper into services in the next video where I'm focusing on Firebase and WebRTC or the video part, but this is everything I'm going to show about services in this video. And then we have the final element, routing, or making sure that when the user clicks on a URL that the correct page is being displayed. It has traditionally been the responsibility of the backend to give users a new page when the URL changes, but this has now started to move to the frontend with single page applications. This is moving the responsibility for rendering the correct page from the backend to the frontend, or more specifically, JavaScript. We can implement single page application routing in our application by just changing it so that each time the user changes a page, that would usually go to the backend now goes to the index.html file. And that's why we're setting the history API fallback to true in the Webpack config file. We intercept this in the frontend with the history object. This is a global JavaScript object which allows us to interact with the browser's history API and save some state on each route, saying which component it's associated with. We can then listen for the window.adEventListener pop state, which triggers each time the browser navigates back and forth. And we can then retrieve the state from that event and use it to render the correct component. Though, one missing element is rendering the correct page when the page is opened for the first time or the user refreshes with F5. And that's all about reconstructing that page based on the given URL. Time to see some code. The page router component is responsible for rendering out the correct page, and it's less than 64 lines of code. And the HTML file is empty as it renders the correct component on the fly. And it's also the most top level component, as you can see here. That means it has responsibility for the entire page and which component is being rendered based on the route. It does this in the connected callback, which is called when this component is created. Here it starts by getting the current page from the URL. As I said, you have to reconstruct the first one on the initial render. And this is just going through the pages, which is a list of all the pages available in the application, the given route, which component is associated with it, and the title, and finding which one is matched based on the window.path name. Here you can see that the location path name for the about page is /about, which corresponds to the same as I've used in the path here, or the part after the localhost and the port. And now we are ready to render the correct page, because we have saved the current page in the object, which is more or less this object. And then we call the render correct page function. Here we start by finding the previous element, if there is any, and removing it, the previous page element or the previous page being displayed. Then we are creating the new page based on the component name, which is this one. This is how we create in-memory components. And then we assign it ID, so we can remove it next time the page changes. We add the event listener so that the component itself can tell us when it wants the page to change. An example of how this is done is here, where you're creating a custom element, saying that we want this page to change to home, and dispatching it. The next step is adding it to the shadow root or to the component's body, so the component will be rendered and displayed. And the last step is updating the title for the document to the correct one. But how can we go to new page? The current page can output an event called change page and send along which page it wants it to change to. This is an object that's the same as this one or any of the ones below. So it sends along which page it wants it to change to, and that is passed to a function that saves it to an internal variable, and then saving it to the page history API, which has three properties. The first one is the current page object. This is the state object, which we can use later to reconstruct the current page when the user navigates back later. And then we can save the page title and the URL associated with that route, which is more or less the window.location.origin plus the current path, this one. And then we just render the new correct page based on this information, so this function is rerun to render the new one. And then also tear down the last one. The last element is intercepting when the user clicks the back button in the browser and then rendering the correct page based on that. We're setting up an event listener in the connected callback or the onInit function. We're going against the window, add event listener, pop state. This is called each time the user navigates back and forth in the navigation history for the browser. And we're just checking if the state is set or this object is set. And if so, change the current page to this one and render it. And if not, we're just setting it to the default one. Really simple. And that's it. That's how you do front-end routing in less than 70 lines of code. It's surprisingly easy when you try it. That was all of the major features for the framework, but there are some missing features. The first missing element is TypeScript. This is something I considered adding, but I'm going to do it as a separate video sometime in the future. This would add type safety on top of what I already have, which would make the framework even better, and it's super easy to add with Webpack, as you just say that it should compile the TypeScript files to JavaScript before it's handed off to Babel. The next missing element is a rendering loop. This is a feature of modern frameworks, where it's re-rendering the component's HTML when something in the component changes. A key benefit of a rendering loop is the ability to define a variable in the class and have it automatically be rendered in the HTML with a syntax similar to this. This would also give us the ability to change the variable and have it automatically be updated in the component's HTML when it changes. Since we don't have a rendering loop, you're also missing out on two-way data binding. Two-way data binding is a really useful feature in modern frameworks that allows you to not just update from the component to the HTML, but also the other way around and then back. And these missing features and some more means that this is not a complete framework, but the key elements are present. Okay, so it's pretty obvious that you shouldn't use my framework in your project, but if you like web components and want a good framework, then I highly suggest looking at Polymer. This is a framework/library by Google that will make it a lot easier to work with and create good web components. But this means we are finished. Thank you for listening to this video, and I really hope you learned something new and exciting about modern frameworks, or at least something cool about web components. The next video is going to cover WebRTC and the video part. Subscribe if that sounds interesting. And you can also play with the online demo if you want, and the code for the entire project is available on GitHub, links in the description below. So, what do you think? Are you going to start using web components from now on? Let's meet in the comments below.